Washington State University. Go Cougs!
So you're probably going to start off with declaring a variable to store an integer, as I've done here. And then you're like, okay, well, I need 5 integers. I've got 1, so I got to do this 4 more times. So you might type out the next one, and then you quickly see that that's not very efficient, right? What's a more efficient way to get this done than typing it out 3 more times? Copy paste, yeah. A lazy programmer is a smart programmer. So you're just going to copy and paste this and save yourself some time. Make sure you don't make any errors though. So we'll come back and change these so we don't overwrite our previous values. So now we're done with the first part. We've got 5 integers from the user. num1, num2, num3, num4, num5. Those are our 5 variables to store our 5 integers. Okay. Now we need to compute and display their average. And now would be a good time to test your program too. Make sure that you can get those 5 numbers in. You can even print them out if you want to make sure that everything's working right. So we've got these 5 numbers. We want to compute the average. What's the first step to computing an average? Yeah, add the numbers up, right? We need a total for our numerator. So we could have another variable called total, which is just the sum of our numbers. This would be a good time to probably check and make sure everything is working. So I might just print out total, just to make sure. Okay, so I entered 1, 2, 3, 4, 5, and it told me the total is 15. So I'm like, okay, great. I think I'm ready to move on. So I'm ready to compute the average. So what's my average? Confidently, what's the average?
3.
That is, yes, that is the correct result. How can I tell my program to give me that result?
1, 2, 3, 4. Average the number 1, 2, 3, 4, 5.
Right? I've added them all together. I've got total, right? So after you add your numbers together, what are you doing in your head to get 3? Dividing by 5. Yeah. No, we're going to find out if you are right? Our program's going to tell us, which you are right. So, and I got to print it out. Print out average. And if you don't want to enter the temperature each time, you can just surround that code in a multi-line comment and it won't execute anymore. 1, 2, 3, 4, 5, and it is 3.0. So nice work. Right there. All right. So while you guys are catching up, what if I told you to compute the average of 10,000 numbers? What? That would be very painful, right? Your computer can do that really fast, right? But we'd have to copy and paste this code. We'd have to change this code. It would be awful. So I can assure you that that's not how large programs work. You don't just copy and paste the number of times you need something to be done. And that brings us to our last basic Python concept we're going to cover, which is repeating code with a for loop, which makes your programs very, very, very powerful. Very powerful. So I want to change this code, and you can follow along if you want, or you can just watch. It's up to you. I'm going to change this code so that it uses a loop. And what a loop does is it repeats the code we tell it to. So I need to get a number and add that number to the total 5 times. So I'm going to say, hey, Python, here's the code I want repeated 5 times. So let me just make some room here. So I need to get a number, and I need to add that number to the total 5 times. So let's say I have a variable called total. Initially, it's 0. And then I'm going to add to total plus num1. This is the code that I want to repeat 4 more times, right? Prompt for a number, add it to my total. Prompt for a number, add it to my total. 3 more times. So I'm just going to tell Python, do this 5 times. So right before it, I'm going to type, very specifically, for I in range 5, colon. Don't worry about this I here, not important for what we're going to do, but this 5 here is very important. This is the number of times that this for loop, this loop, is going to repeat this code. However, just like we had to indent our print statements in order to say, hey, here's the code we want to do when this if statement is true, here's what we want to do when it's not true, we've got to indent this code so that Python knows this is the code to execute 5 times. If I put 10 in here, it would do this 10 times. So I'm going to go ahead and delete all this code. Okay, I'll just put it in a comment. So this isn't going to execute anymore. And I'm going to run this. Okay, so it's prompting me for an integer. So this is coming from line 31. Enter an integer. And I'll enter in 1. And then it's saying enter an integer again. Remember, this code is in a comment, which means it's ignored. So this prompt is coming from line 31 again. Okay, this is pretty advanced stuff. Okay, it's okay if you're like, what is she talking about? The main lesson here is these 2 lines of code are going to be repeated 5 times. So here's line 31 executing a 2nd time. Here it is executing a 3rd time. Here it is executing a 4th time. And the last time, the 5th time. And then it stops. Notice how we did not get enter an integer a 6th time. Line 31 didn't execute a 6th time because we only told it to execute 5 times. Oh, okay. Let me get rid of that. 45, 1, 2, 3, 4, 5. And there's our 3.0. Okay, take a deep breath. I'm not going to ask you to do any more coding. What questions do you have about what we've learned so far? All algorithms, which are just sequence of steps that solve a problem, are composed of these 3 types of statements. Sequential, execute one line after another. Conditional, execute some code if some condition is true. And iterative, repeat statements with a loop. All algorithms. Google's PageRank algorithm, artificial intelligence algorithms, all composed of those 3 statements. Sequential, conditional, and iterative. It's crazy. But major in computer science, switch majors from psychology to computer science, or double major. It's really powerful. It's really cool, right, Jason? This stuff is what we love. All right, questions. All right, if you don't want to ask me, you can ask Jason later. Sure, he'd be happy to answer them. But that's all I wanted to show you guys for part 1, which was kind of, you guys have your hands on the keyboard and write some Python code and see it run. If you guys have time, I'll do 1 demo. Just sit back, relax, watch, take notes if you want to, and then I'll turn you guys loose. You guys are okay with that? Okay, cool. Because this is kind of answering your question, right? Like, how does all of this come together to make something really cool? All right, so I'm going to do a demo of Jupyter Notebook. You can follow along if you want, but I'm going to go a little fast. All right. So back in Anaconda Navigator, there's another program here called Jupyter Notebook, web-based interactive computing notebook environment. edit and run human readable docs while describing the data analysis. So you guys all work in a psychology lab, right? You probably have lab notebooks, right? Where maybe you describe the experiment you're about to do, you do the experiment, you record your results, maybe you draw like a little sketch of what you think those results mean. So this is a digital version of a notebook, specifically for doing data science, where your experiment is reading in some data, running some code, and looking at the output. Maybe you're looking at it like you would look at it in Excel, or maybe you're plotting it like you would plot it in Excel. And you can do that all here in Notebook. So I'm going to make a new notebook. Think of this like turning a new page in your physical notebook. And this is what it looks like, which doesn't look like much. But very quickly, I'm going to make this look almost like a web page. So first off, I've got something called a code cell. Okay, you know it's a code cell because it has this in bracket in front of it. And I can execute any Python code I want here. So let's say I head back over to Spider and I copy and paste this code here. And I can run it right in the browser. Okay, this is running in Google Chrome. Here's my code, I run it, and notice we don't have that weird looking console, that command line. We've got this nice text box here that almost looks like a web page. And we've got a crash already. Got to declare my total variable. All right, 1, 2, 3, 4, 5. And then it shows me the output right beneath it. So this is cool. If you're not convinced, I'll show you some more cool things. So let's say that I have some more code cells here. I can move this code cell down. Make this a little smaller. I can move this code cell down, and I can have other code cells up here. But in between these code cells, I can have markdown cells. And this might seem a little overwhelming, but I know one of you said you know HTML. So Markdown is a really convenient way to write HTML. There's no tags, there's no angle brackets. It reads very much like English. So let's say I want to add maybe like a title to my notebook. So a single pound sign is like a H1 level 1 header in HTML. And maybe I'll say something like WSU GSIR Python demos, something like that. When I run my Markdown cell, it's rendered like Google Chrome renders an HTML file. And that's how it looks. So now let me go a little faster. So maybe I'll do a level 2 and I'll put the date. I think it's the 18th. And maybe I'll put my name. Okay, that looks cool. Maybe I'll head over to the CASA's website and I'll grab a link to this image. And I will put this image at the top of my notebook. And now I've got kind of like a letterhead looking notebook. So this is pretty cool. It's looking good. I can add links to external sites. Maybe I want to link to, let's see, WSU GSIR site. So I can just copy that, edit this, and let's say I want WSU GSIR to be a link. Okay, I can make that a link. Okay, and now this looks like a hyperlink that you guys know about from websites, right? It's blue, it's underlined, and I click it, and it will bring me to the Gerentech site. Okay, so what does this all have to do with Python, right? I'm just having fun. It's the honest truth. But it has a lot to do with Python because you can tell a story like you would in your lab notebook with this, right? So let's say, really quickly, I'm going to read in, I think I have the file downloaded here. Yeah. So I have this file here. It's got some daily steps collected from Fitbit in a CSV file. I can open this up in Excel. And here's what it looks like. Just a grid with a bunch of numbers. I've got dates on my columns, and I've got minute by minute timestamps on my rows over here. Let's say I want to open this up in my notebook. So I can do this pretty quickly. So I'm going to use something called read CSV. It's a CSV file. I'm going to specify the name of the file. I'm going to set the index to be the first column, which is essentially like a unique identifier for each row. And I'm going to parse that first column into dates. Okay, so I've just read in that whole file in one line of code, and I'm displaying the first 10 rows of that file. And that looks just like you saw in Excel, right? Just like you saw in Excel. But I just opened this up using Python. So really quickly, a few cool things you can do now that I've loaded this data up and I've got a variable called df, short for data frame. I can get some quick statistics on it. So I'll do df.describe. And I don't even have to write that algorithm with that for loop to compute the average for each of my columns. It does it for me. So here's the average number of steps taken per minute on October 1st, 2015. Clearly, October 4th, 2015 was a much more active day, right? You can see that really quickly, and that's only my 4th line of code I've written. So this is Python for data science. And I have to show you one more thing, and then I promise I'll stop. So let's say I want to quickly plot this. I can do this in a few lines of code as well. So I'm going to import a plotting library. And then I'm going to plot, let's just do the first day of data. So whenever you do like a line plot, you got to have your x values, right? And the corresponding y values. So I'm going to have the x values be the index of my data frame. And my y values just going to be this first column. And then show my plot. And there it is. OK, I have so much more to show you, but I won't. But everything I was going to show you is on here. So demo 1, we mostly got through. Demo number 2, data cleaning. Actually, Jason was just talking about this morning. So, I mean, doing the visualization and the machine learning and building models and prediction, all that stuff is fun. But truth be told, most data scientists spend their time cleaning data. And I have this nice graphic here from Forbes. What data scientists spend most of the time doing, and sadly, 60% cleaning and organizing data. And I've worked with some of the psychology data sets here. Those are used in demo 2 and 3, well, one such from the smart home. And a lot of that data is inputted manually, right? I don't know if you guys have worked with a smart home or you've entered any data from some of the labs that you've participated in. You enter it manually, right? And it's inconsistent across people. So data scientists like Jason, he'll spend hours cleaning that data so that when he opens it up in like Pandas data frame, for example, he can make a query and get everything that he wants to match that query. And demo 3, just grouping the different types of participants in that file. And then I did like half of demo 4. But at the very end, the very bottom, there's 2 links to those resources I talked about at the beginning. So the WSU AHA, that's a program that Dr. Cook and Dr. Schmitter-Edgecombe are running, where they have a lot of online course tools for learning about how to essentially work in this sharing technology field. And I have a few modules on Python for data analytics in there. And then Computer Science 111, I taught that class here at WSU. All that stuff's online if you want to do some of the programming assignments. You can almost pick up right where we left off here with part 1. And then my favorite book is Python for Data Analysis by Wes McKinney. And this guy's amazing. He actually wrote, well, he's the main author of that data frame library I was using to read in all that data. So he has kind of like the handbook on how to use Python for data analysis. Read it cover to cover. It's amazing.